on page 233. When we find a tangent line to a curve, notice I say tangent line. That tangent line tells us a lot about that curve right there. If we were to find other things, like if I wanted to point really close to it, I could find the value of it. And that's called using linearization. That's what it's called. Well, today we're going to do linearization and then also find some values. There is a formula for linearization, and we'll let linearization be represented how appropriately by the letter L, which is kind of unusual sometimes, isn't it? And linearization is equal to f of a plus f prime of a times x minus a. That's what linearization is. And what we will do when we find linearization, find the value. By the way, I told you two things. This is the first one. After we find linearization, we are going to make a comparison. Do I need a hard one or an easy one? Since you all are my quiet group, what?
Really quiet because Nate's coming.
It's Jillian.
Oh.
Here's my function. F of x equals this. Excuse me, we're going to let x equal 0. Okay? So I'm going to find the linearization. First of all, it asks for f of a. A is 0. What is f of a? No, when the square root is provided, it is just positive. Only when you put the square root in do you do plus or minus. So is f of a 1? So I have 1 plus, what is f prime of a? Did you do f prime? No. Is f, if f of x is radical x plus 1, is f prime of x equal to 1/2 x plus 1 to the negative 1/2? We forgot that? So is f prime of 0 equal to 1/2 times the square root of 1, which is 1/2? Right? So it is f of a is 1 plus f prime of a, which is 1/2 times x minus 0. Is that right? Are you with me? So is my linearization equal to 1 plus 1/2 x? Right? Once I have found the linearization, was that pretty straightforward? Once I have found the linearization, I want to compare this. I want to compare L of A plus, make sure I write this right, 0.1 I want to compare it to f of a plus 0.1. What's L of a plus 0.1? What? Doesn't this mean in place of x, I put in 0 plus 0.1? What is that? You don't know.
1.1. Is that what you said? 1.05.
1.05? Okay, what is f of 0 plus 0.1? I go back to f here. What is the square root of 1.1?
1.0488.
1.0488. How close were those? Pretty close. They're like 1/1000 if I rounded to 3 decimal places.
Can you remind me why 0.1 is in there?
Why this is in here? Because that's given to you to do.
Oh.
So you have two answers. The first one is, what was the linearization? Which you said was this.
Where can we put the f of a plus 0.1 into? Like,
The original function, f. Uh-huh. So you had two answers. Your first one is what is L. Your second one is to compare these two numbers. Does that make sense? That's what linearization is. How close is this getting to if I plugged it into the regular value? That's what you're looking at. That's the first thing we're doing. Second thing we're doing is Newton's method. Newton's method says when I find a derivative, instead of just writing y prime, I write the derivative as dy over dx. And if I give you a value for dx, can you find it? I'm finding a good example. Is there a good example? How hard problems do they give you? We better do more than one. If I give you this, f of x is 3x to the fourth plus 2x. I want you to use Newton's method. And I'm going to tell you that x is 1 and dx is 0.01. And I want you to find the value. I want to find dy. Isn't this y? So the derivative of this is dy over dx, which is another way of writing derivative, right? Is equal to 12x cubed plus 2. Do you agree?
Yes.
So is it true that dy equals 12x cubed plus 2 dx. Is that true?
Yeah.
So does dy equal, can I plug in, I know x is 1 and dx is 0.01. Can I plug that in and get dy? So when I plug in 1, I get 14 times 0.01. dy is 0.14. Pretty simple? It is pretty simple until they put a y in the middle of your equation. Isn't that nice of them? You ready to do one of those?
Yeah.
X plus y equals xy. What do I know? X is 2, dx is 0.05. All right, I have a choice. Every time I take the derivative of dy of y, I can write dy over dx. Or every time I take the derivative of x, or y, I can write dy, and every time I take the derivative of x, I can write dx. It works the same. That might be easier when I have a product, because then I don't have, is that okay with you? Okay, so for x, what is the derivative of x? Dx, right? Plus, what's the derivative of y? Dy. Equals, oh, this is a product rule, right? Which is the first times the derivative of the second plus the second times the derivative of the first. Right? I now need to solve for dy. Is it okay with you if I put numbers in instead of letters? What?
And the value's given, is that what you're putting in?
You're gonna plug in the provision too, is that what you're saying?
Huh?
Are you saying you're gonna plug in dx?
And x.
Okay.
But can I plug in y?
But you can't.
Can I find y?
Can you?
Yeah.
Could I find y? Can I go to my original equation here?
Oh, yeah.
And it's 2 plus y equal to 2y. So I'm going to move y to the right. All right? So 2 equals y. Right?
Mm-hmm.
So now for this equation, I can plug in x, y, and dx. Right? So 0.05 plus dy equals 2 dy plus checking my math here?
Yes.
So what should I do? And what do I get? Subtract 1, yes? That gives me negative 0.05, I think. And subtract dy equals dy. That's my answer.